Hello, welcome back. I hope you guys are still here. There has been some problems with setting up the stream, so I'm gonna again give a few minutes for folks to join, and I will also tweet again. All right, just checking out. Are people back? So Ihab and Shronovi, anybody else? Also, let me bring some music. All right. All right, let's get started. I think we can kick off and see if any other problems arise. All right. Cool. All right, so switching now to my screen. So last time we, and also by the way, I've added a new feature. I hope you like that one. It's so you can now see my keystrokes, I think, on the screen, which should help if you want to follow along how I use Vim, for example. Let me know if you like this one. Cool. I've also shared the code on GitHub, so you can now access the code. I will share a link for the code right now again, so that everyone can follow along. It's on my personal GitHub account, and I've picked the name. So here is, I'm gonna put that on chat here. All right, so it's Ahmed Soliman /Kling. I hope it's not a very cheesy name, but I found that it's available on Crate.io, so Kling sounds like a great name. Cool, let's get started. So screen sharing now. Great. Cool. So I've also, made some basic setup for the structure here, just to make sure we have something to play with instead of spending the time all setting up cargo and workspaces. So essentially, there is a workspace right now that has a single crate, and the crate is called Cling. And you can, you can see, you can access the code on GitHub as I've shared. So now let's move on to setting up the basics. We have examples directory here, and this is where we're going to be kind of experimenting with how the framework behaves. And it also serves as a double purpose. So you can have this as an example or multiple examples for people to follow if they want to know how to use the framework. So the only thing the library has is Prelude, which is just an empty module. And essentially it re-exports the bits from clap that we need to expose. And this way, anyone who wants to use Cling, they can just use Cling Prelude and everything in it. And then they don't have to, get clap directly or so it's kind of like batteries included sort of setup. Cool. So now this is the example similar to the last time we had, and that is just a simple structure that accepts a name. And last time we had subcommands and subcommands for subcommands and all of that jazz. Now today we want to shape the API. So we want to kind of imagine what is the API going to look like? Take inspiration from Axum as we have seen last time, and also maybe go here and there and imagine the different versions of API that we can have, the different styles. So let's actually get started by actually making this example something that actually works. And to do that, I mean, the simplest thing is to look at what we have done last time. So last time is we had, I think, something called Axum for CLIs, yeah. Oh no, that one, not that one. Let's actually remove that one. For CLIs. C-line. Oh, now it's gonna get confusing. Yeah. Here we were actually imagining things. So I'm gonna actually copy that. So I'm gonna copy that structure. And maybe give these a little bit of a better name. That was one of the feedback that I've received, is that like test1, test2 as commands, like it might be confusing for people. So I'm just gonna make it a little bit such that it represents maybe a real command or something. That could be a little bit easier for folks to follow along. So here in examples, I'm going to create this, just remove opts. That's the one I had here before. And the top level is CLI, and also let's rename this one. So let's call it, I don't know, CLI opts, might be a little bit better. And our commands, let's assume that it's like maybe a calculator or something, or like one of the commands is calculator, and then you have add, subtract, to make it a little bit more easy for folks to follow along. We don't really need config. We can just have, in the common options, we can have debug or maybe verbose, but debug sounds great. And here it accepts like multiple. Yeah, you can pause it like several times. So it can be -d, which means like more debug. And key commands that we have here is test1 and test2. Let's call this calculator, calculator opts. And let's call this something like, who am I? Actually, good point. Let's actually make this a unit enum variant, so that we also won't support this. So we won't support where there's a command that doesn't take any arguments, that doesn't take any options. We need to support that as well. And here, this should be cleops parse and prints hello world. There's of course no calculator ops. We need to remove that one and call this calculator ops. And this one maybe takes 2 arguments. Actually, no, this should take a command, another command. So let's actually do that. Yeah, and the command here is, maybe we can call this operation. And the enum here is going to be calc operations. And similarly, we're going to have, I'm going to just move this up there and have a very similar structure to this one for calculator operations. So we're going to have calc operations. We can have something like add, subtract, yeah, something similar. Just let that one here. Yep, we need to create these structs. Let's actually see if this can generate it. Generate trait, no. Yeah, it can do that. So just need to maybe copy this one here. I'm gonna call this add opts, which is gonna take, I don't know, num1 and num2. Both are U64 maybe or something. Let's see if this works. And similarly, we're gonna have subtract, add opts, subtract opts. And also, yeah, it's gonna take two numbers as well. Let's actually see if this compiles. Well, it compiles. And we have a command here. She paused this by -- calculator. Right, it takes add. So you can see here actually calculator itself takes one argument here. That's arg1, which just maybe sounds confusing because we have test1. Is test1 still used? Let's close this one. We don't need this in anymore. All right. Where's arg1? Yeah, arg1. Okay. So in calculator ops, let's actually make something imaginary here. Let's assume that we need an argument to control the color of the output or something. So color, and that would be Boolean, right? So if color is on, then we print the output in color. So we can actually add some documentation here saying that enable color output. So this way, at least it looks a little bit more meaningful. And add can take now two numbers, as you can see. It doesn't really do anything. But here is where we need to build this dispatch system so that we need multiple things. Like we need to execute, as we said like last time, we need to execute some logic on every layer. And also we need to have a mechanism to pass along the arguments for every layer down to the last command. I mean, accumulate it in a way, and then let the handler of the last command have the option to whether it needs to see all options or like its own options, or the option for that particular command and the parents all the way up. So I think it's going to get a little bit clearer once we start actually writing some dispatch code. So we have multiple ways here to really think about this. I've seen a common way that folks use, and I've used in the past, is to implement a function called run on every command trait, an enum, like this one. So for instance, you would have impl calc and a function called run or something. So pop fun run, and here you would need really to decide like, okay, which arguments do I need, and take those arguments. So what happens in this case is that because you're executing, I mean, we're going to execute the function run on calculator opts, and let's say it takes self. The implementation needs to have a basically switch statement. Like you need to pattern match which command you are in, right? Like is self add or is self subtract, and that can be confusing for many people. So And not just confusing, like it can also be time consuming. You're gonna have to repeat that code over and over. So what we really need, we need something like this, like run add, and in that case, like self itself wouldn't be very necessary. What you want is add opts. And it would take add opts, right? And another one for run subtract. And well, if you think about it that way, and that would be, you know, sub opts or something. If you think about it that way, I mean, this doesn't take self, so it doesn't really necessarily need to be within the enum. I mean, you can remove it out. And well, if you do that, then that actually starts to appear similar to the handler function that we discussed last time. But if someone, you know, wants to implement run add and they are also interested in setting up the color, assuming that there is no common color, you know, common logic for calculator ops or something. Like, let's say that we want to, like, everyone who wants to execute run add, they would need to check if color is enabled and print something, right? So there is some setup that needs to happen here, and some state that needs to be shared. And this is similar to Axum that we have also seen before. So now let's think about if we are going to do this in a way that we want, so in a design that we like, but manually, without a framework. So how will that look like? And that's a kind of a good way to, you know, build anything into a library, like build something that uses that library first. And, you know, if we're going to have a macro, then we write the code first, and then we write the macro that generates that code so that we can get rid of it. So we want to rely heavily on code gen if possible, and also derive macros if we can. So ideally, you know, we want something like this. So we want to get to the CLI opts, that's the top level one, and have a derive cling. Right? If we have this, it means that we can have in parse, instead of parse, we can say maybe init cling, or maybe just parse as well, and then ops, and then we can say ops.run return ops.run, and then the main in that case would return result. That's also something we need to consider. One thing can be very helpful if you actually look into the README of that repo. I've written down a little bit of the requirements or some of the high-level design ideas or direction, at least, that we want to get to. So you can read that while I sketch out this result structure, which shouldn't really return anything, but maybe return then or box then error. I should just actually, you know, one of the cool things as well, if the framework provides a standard CLI error like this, like if there's a structure that the framework provides that can communicate all the way up if there is an error and what the error is, then on the top level we can capture that error, print it in a nice way, and also colorize it, return the correct exit code for, so, you know, non-zero basically, and maybe also whoever passed up that error, and they can also maybe choose which exit code they want to have. So that also can be something, you know, that can be something cool. And you can actually find it here. Like I mentioned this, yeah, in line 13 here, like translates result error into non-zero exit code. So that could be basically maybe one of the first things we do is in Cling itself, I guess our library here, we create a file called error, and let's define it. So So essentially once is enum, let's call it clear, like this one. Needs to be pub, obviously. And let's use this error. We obviously need to put this in lib, but actually, yeah, let's make it public, but also let's put it in the prelude. I think it makes a lot of sense for that to be top level. So pub use error cli error. And let's derive error. And have something. Oh, what happened here? Let's have a couple of variants. At least let's have one variant like abort right now. And we also need abort, like which takes maybe just abort and then abort message, which takes message string. And we need something pass through. So anyone who uses anyhow error can just return the error, and it would still fit in this one. So we need to be able to take from, like, we have a common blanket catch-all variant. So let's call this other. And this one will take, I think its syntax is like this. We can say it's from anyhow error. And this is error transparent. And yeah, this needs to be debug. I think clone might also be a good idea. What else? This needs, yeah, so we need a couple of things here. We need to have an error message for this. This one aborted. And this one aborted and maybe 0. So that's the message that the user supplies right here. Yeah, and we don't have anyhow. Actually, we don't depend on anyhow. And that's interesting one. We can say, okay, so we don't, and I actually don't want us to depend on anyhow. Anyhow is mainly used for binaries, not libraries, and we are a library. So what we can do here is we can replace this by a boxed. So basically any box of then would be fine. I think that would work. I'm actually not sure. Let's see what is here. So tray bound clone is not satisfied. Yeah, that's fair because it doesn't know if this is clone. One cool thing actually is we can take a look into anyhow error and see what is that type. Alternatively, we can temporarily add basically depend on anyhow error for now. So I'm gonna do that just now. So for dependencies, I'm just gonna add anyhow. This is cargo configuration if you haven't seen this one before. All right, so that should really work right now. It's compiling. Just need to import this one. Actually, we don't need to import this one. This should be... Okay, let's drop the clone. I think it's just adding more hassle than benefit. Okay, this one seems to compile. This one is complaining that unresolved import, considering, oh yeah, okay. Makes sense. Yeah, cool. So now this actually should work fine, except that, our simple example has a lot of crap that doesn't really exist, like that run function that doesn't exist. I mean, that should be what the framework generates for us. There's also this cling derive, which also doesn't exist, and we need somehow how to implement it. Let's first take a look in the chat and see if there are any questions. Right. All right. For some reason, my... All right. Can you see me now? I think my video stream was frozen for some reason. Hey, Alfie. Hey, Mem. It seems I need to watch first episode, definitely. A part of the design doc is behind the chat. Design doc is in README. And the README is on the repo. I've posted the repo on the chat. I can repost it right now if you haven't seen that one. So again, that doesn't work. Yep, should work now. Cool. So sounds like no questions so far. So let's keep going. And again, like I've shared in the first stream, this is not like educational video in a sense that I'm kind of teaching people something. Well, if there is a topic like you'd like to ask about, I mean, I'm happy to discuss. But the whole point here is that to see me exploring, figuring things out and designing things on the fly. This is not like pre-prepared recipe of code that I'm writing. Great. So we don't have cling, of course, so I'm going to remove this one, but we're going to assume that that thing cling exists, and we will need to think about what is cling. Like, what does that generate? So what I want to do right now is I actually want to write a function handler. So let's have an imaginary function handler right now for add, right? Let's think about how it would look like. Also, by the way, just to add to the complexity of all of that, we should support async as well. So our main should support async. That will add significant complexity to some of our trade bounds and all of that, but it is what we need. But before I get there, I actually start with the sync version, at least to make it simpler, and you can get like the general picture. And then we can dig deep into how to do that in async. So let's see. So now let's actually implement this function. So let's say that we want to say run add. And let's imagine, so that is my handler. And let's think, what do we need here? So to do add, like basically we need the add ops. Like this is where we have the two arguments, right? So we need, all right, add ops, and that should be add ops. And arguably a reference. That makes some sense, but it definitely will add complexity when we talk about async. So I'm gonna make it by value right now. And by the way, we need to require that all of these are clone. Either we generate it automatically, like we add clone to every one of them, or we make it manual. So for now, I'm just gonna clone things manually, or at least like add the derive manually. We'll need to think about how can we make it easy for folks using the framework, whether we will ask them, hey, you need to add clone on everyone, or whether we will, as part of our derive, is to also automatically add the clone derive. Clone here means that we, for folks that don't know what clone is, clone implements a trait that allows us to use .clone on any object, so it can copy that object. In Rust, you have to be explicit about that. Yeah, cool. So run add. So what does that do? This should basically convert the two numbers into, well, actually they are already numbers. So we just need to add them, print, right? So print maybe something like this, right? So add ops.num1. And let's see if this works. It might. Actually, it should work fine now. Additionally, this function actually should return CLI error or any sort of error whatsoever. And also, it should be optional. Like the user should have the choice to either return an error or not, right? We want to advise everyone to return an error. Well, it should actually be result. I mean, yeah, something like that. And in that case, because there is no error, we're just going to return OK. Cool. All right. And maybe there's a condition, right? Like maybe there's a condition, like if the number one, I don't know, larger than a specific value, then we print an error or something. I mean, we can do that later, just to show how the error plumbing works. Yeah, but right now, I mean, we have the handler. Looks great. But how do we get from the parse arguments to the handler? How do we execute this handler? This is where the fun begins. So in principle, what we need to do is we need to match. So match opts.command. And for every case, which we have like two here, right? So we have calculator and who am I? Who am I? I'm going to leave this as to do. I don't really care about it right now. I'm just leaving this for kind of structure purposes. But calculator takes, this is what takes the calculator opts. So calc opts. Right, so here in calc opts itself has command, which I think is called operation. Yeah, so we also need to match this. Let's fill the matches, and here add takes the add opts, subtract takes sub opts, and right here, so this is where you need to call run add and pass in add opts, right? So now we're passing this by value. We don't really need to require clone, I think. Well, it depends. We're gonna see actually later if we really need it or not. Subtract, I mean, there is no implementation for subtract right now. So what we can actually also have is we can have a blanket implementation that really does nothing for those commands that have no implementation. So let's say function no op, and that one returns also result CLI error, and it really does nothing. For those ones, like instead of to do here, we are just gonna call no op. And you'll see like, okay, we're not really using sub opts, but that's fine. All right, so what are you complaining about? So this one also returns here. So, okay, so found. Yeah, we also need to remove this one. And yeah, that actually should work. So if we really run right now, yeah, so calculator add, I mean, this is a warning just because we have an unused variable here, which is fine for now. But add 1 and 2, you know, prints 1 plus 2 equals 3. This is exactly what I expect. Yeah, and if we do subtract 1 and 2, it should have no op implementation because we didn't really implement anything. Cool. All right. I think there is cargo has quiet. Yeah, there is quiet, but it doesn't remove the clippy warnings, which is okay. All right, so looking at chat right now, is this a code we want to get rid of with cling? Yes. Yes, I'm kind of showing here like that's one example of dispatch. And like something to carefully consider here. Let's say that whoever implements this also wants to have color support, right? So basically something like this. we can say if color, but we don't know where color, what color is. I mean, color comes from the upper command options, which is in our case is called calc operation, calc ops, I think. It's this one, sorry, calculator ops. Right, so we need to pass calculator ops down. Or we can have something similar to this one, where like we collect everything that's common about this particular calculator ops. So something like this, pub calculator. Name is going to be a little bit tricky. Calc common ops. Or maybe another just common ops as well, just to confuse everyone. Yeah, the other one we called common, so let's also make this common. But it of course, it's a different structure, so it's not common ops, it's like a calculator common ops. And we're going to take this one into that structure. This one also needs to be transparent, flattened. Yeah, flattened. And so you can get this one from here. What else? This needs to derive parser, debug, and clone is not really necessary, but I'm just going to put it for now. Okay. Yeah, there is actually a problem. If we asked everyone to do that, like everyone has to combine all the common options into a new structure. And there's a reason why I'm doing this in that particular way. But we actually really don't have to. I mean, maybe there is an alternative, the design alternative that allows us to not do that. Okay, let me actually leave it as before. Yeah, let's leave it, right? Like it's a design challenge. Like we want to support that particular structure. So a struct can have any number of arguments, right? And a command. So here it's called calculator opts. And here, if you want to have like if condition on a color, you really need to have access to that particular structure. So in that case, it's going to be, calc opts, which is calculator opts, right? And in that case, so you can actually have access to this. So calc opts dot color. Yeah, so you can say if color, we can bring colored, if I remember correctly, version. That's not a good practice. This is just to print some colors in command line. So you can say, okay, if it's, so instead of printing, we're going to format and put this in a string. So let's output to something just to simplify. Right, and if there is color, we're going to print line output, and actually no, we can do that. It needs to be output.red. Does that work? Else just print line output as is, which should really remove that one. So it will complain, okay, wait, I don't know what red is. Yes, and this is where we need to import this trait, colorize. So if you have colored, colorize, then output will be red, which is weird for calculations. Make this green or something. Right, so if we actually execute this one, I mean, it shouldn't really compile, because what happened here is that we added an argument to our handler, and we need to do all the plumbing. So remember, like that is the issue I was discussing last time, is that we need that plumbing to be automatic. Like if I said, okay, I need to depend on this structure, and it happens that this structure is in the path of execution to your command, then I just need to add the argument into my function, and the plumbing should happen automatically by cling. But how to do the plumbing manually here is that we need to pause this argument in run add here. This is, like that's the error. Like it takes two arguments. We have only one. Where do we get the other one? We get the other one from calc opts. And here I think we're going to see a problem. Yeah. So we're going to start seeing a problem here because calc opt, that is what I was thinking about previously. Calc opts is partially moved because we have this match operation on by value. So operation is moved, and we are passing the entire thing down. And an easy option to get around this is to just match on references instead. But when this happens, you only get references as well to your arguments. So we can't really take these things by value. We can just take them by reference. And that actually should be fine. It's even more efficient in some cases. So that's cool. All right, so let's actually run it again. Okay, subtract should really do nothing. Let's do add 1 and 5. So by default, yeah, it prints, but it doesn't have any color. We should be able to add color. That's actually not going to work. Yeah. So it's complaining that we cannot put color here because it's an argument to calculator, not argument to add. So it needs to be calculator color and then add. And here, yeah, see, like it's printed. It's red, not green, because I think my theme. Well, that's the reason. Like my theme is mapping colors like weirdly, so green appears as red and whatnot. We can actually make color available like in every level from calculator downwards by adding here. That's a Clippy feature. We can, I think, add global equals true. Yeah. So now this one should work, which is the one we did before, but also the previous one, which is like add and then color, should also work, and it did. Cool. All right. Can't we just clone for now? We can clone for now, but we also want to. I mean, we're building a framework, so we don't want to be cloning unnecessarily everywhere. We need to be efficient. Like we need to be considered when we're cloning. This is. I mean, I get it that we're playing around, but it's a consideration we need to think about. Like we wouldn't have noticed the problem if everything's just clone and we're cloning everything. We wouldn't understand what is the implication of passing the parent object downwards like this, right? Because in that case, we would actually have been passing only if calc opts had common, that's the one we're going to be passing down. So instead of calc opts, we were going to pass that calc opts.common, and that would actually have worked because that's not that part was not moved when we matched here. We only matched an operation. Operation only was the only part that was moved. So it's just something to think about. Like if we can do the plumbing with references, maybe that's fine. But I also know that this is not going to work for the final version. So for the final version that we're kind of getting to, which is similar to Axum, in Axum you don't get references, you get things by value. So yeah, we might need to clone in that case. Yeah. Another thing that we also need to think about here is what sort of types do we accept here? Like, do we accept any type or only types that has parser on it? So for instance, in our case, we have add opts. Add opts has parser implemented. That's a trait, which restricts what kind of values you can pass down. So for example, maybe subcommand is not something we should pass down because you should be able to, like the dispatch mechanism should already get you to the function without having to think about what's the variant of the enum. You only really need to think about this argument, add opts. The tricky part here is if there are other styles. So instead of add opts written this way, actually some folks might write it like this. And take everything from add opts here and put it here. If that actually, yeah, that actually is legal in CLAP. But then you would wonder, okay, what is the type that we're going to pass down? What is the, what do I expect? Like if I have a handler here, what argument should I get? And add itself is not a type. It's a variant. It's not a type on its own. So you cannot expect add to be passed in. The only thing you can get is calc operations on as a whole. And that's an enum. And that's just very painful, or relatively painful to deal with. And I really don't want to design it in a way that this is cool. So I want to encourage people to, hey, you really need to design it like this. And not just encourage, maybe even enforce. So if you're implementing cling for this, it would, compile time error tells you, by the way, we only support tuples, tuple enum variants like this. And that's actually fine. Additionally, when we are hit by something like this, you also cannot say, okay, I need color on its own as Boolean. That will clash with, if you have many layers and there are so many Booleans, we just cannot recognize which Boolean you mean. So I think having a dependency on parser maybe makes sense, or having a dependency on our own trait, like we can have a cling. All right, cling on every structure that we can allow to be passed down. That might also be something that we want. So if we already have dependency on parser, right? If you can say that, okay, that's gonna be our requirement, then we might not need what we discussed last time. We might not need cling opts. You remember that one which we were discussing out of Axum? It was something like this. Oh no, this should be like this. Cling. If you remember that design, we only need this let me think. That might be actually still required. Okay, so let's get to, I think a good way to think about it is to start thinking, okay, how can I actually automate some of that first? First thing I want to think about is I want to have a trait that all these functions implement. All my handler functions implement. So what I'm gonna do is I'm going to lib, and I'm gonna have a new file called handler. And this one will have pod trait CLI handler. I should have named that CLI handler actually. Let me fix that. Or maybe not. That's okay. CLI handler should be fine. All right, so we have public trait handler. And that trait should have a function called call that returns result and CLI error. Yep. And we need to implement this. So we need to have any arbitrary function like this need to implement this handler. That's the same strategy that we've seen in Axum last time. So let's do that. So let's do impl trait, impl CLI handler for f, and let's start with a simple function where f is f and once. So it's a function that takes no arguments. So that is the first version. Function that takes no arguments, returns result of nothing and clear. Right, we need to make this a little bit way more generic than this. Okay. Okay, so the simplest version here is that a function call should return, this should consume self actually. Yeah. So function call should call self and pass no arguments. So that's an implementation for functions that take no arguments but return result and clear. I would actually argue that we need the same for functions that return nothing. We will still return result, but when we call the function, we will just return okay. So this is to allow folks to write a function that takes, so for example, no op here would be void. I mean, returns a unit. And that would work, right? Because it matches this function, this implementation. Okay. Let's import, let's use cling. Let's put this in prelude. So it should be in prelude already. And following the other design, we should be able to, the other design axiom, I mean, we should be able to come here and say, okay, what we expect is any function that implements handler, CLI handler, and we need something that transforms, that takes CLI opts as an object, pass it down, and then on every layer, every handler, it needs to be able to extract from CLI opts as an argument. It needs to extract whatever it needs, and that's also we have seen in Axiom before. So we can follow a similar structure. We have some compile errors here. Yeah, that's obviously because I forgot to define this as a type parameter. We also need to support having multiple arguments as well. Right now, this only takes no arguments, which is not very useful. Right, okay. This conflicts with this one because it's both for. Does that mean that it's polymorphic in that sense? What is it? Is it question mark? I actually have another idea. Wait, actually, let's research this. I don't know. I don't know what is. Oh, thanks, Chernobyl, for letting me know. Yeah, I'm very used to splitting my screen into two and writing code left and right. Actually, often I split into three. I didn't realize that the chat would be on top of this. So maybe I should either move it a little bit or have a separate split, or not, or split vertically instead. Okay, so what I was okay, let me close that one. What I was thinking about here, so the compiler is not happy about what I've invented here because it says that these two implementations for that trait conflict, basically. I think because it thinks that this and this bound are similar somehow, or one matches the other. And I'm a little bit surprised about this conflicting implementations. So what I was thinking is what would be a type here? Actually, let me comment this. Like if I comment this one, would that compile? Let's see if this actually works on its own. So it says method call has self declaration in the impl, but not in the trait, of course. Would that work? How do they handle functions that are void? I think a good way to do this is to have a test case here. CFG test mod tests. And then let's just write a closure and see if it matches this or not. Right. So test empty functions. All right, so let's have a closure like fn no op, for example. That really does nothing, and this is a unit. Yep. And let's see if no op. Let's have a function. Actually, that doesn't even need to be a test case. It just needs to be. I mean, this is a compile time test basically, so it's not a runtime test. Right? So actually, good mechanism to do this is to say const. Is to do something like this. Is where you put a block of code that really does nothing, and the compiler would fail if it. I mean that logic really doesn't do anything, and that's the reason why the name is going to be underscore. But it will fail if that compile cannot compile it. So fn no op here, and then we can say if we have a function like handle, for example, and that function takes type t, where t is CLI handler. And handler t. The question here, and handler should have call, right? So can my function no op be passed as an argument to handle? So can I do handle no op? Unused result, which is fine. So let's do. So yeah, this seems to compile. This seems to compile just fine. So the empty function that takes no arguments can be passed to handle because it matches this condition, this bound. But if we comment this and use that one instead, oh, what did I do? Oh yeah, okay. Okay, that's better. So now it complains because it says that basically that function does not implement, that doesn't meet that condition, so it doesn't implement this trait because it requires that my functions return result. So I think one way, I have an idea to solve this, and the idea here is to actually be generic over the return type. So instead of saying that my condition is actually fn once returns result, I say, okay, fn, my entire trait needs to be parameterized by ret and returns ret. Or it can be a type parameter as well, by the way, which might be a little bit more reasonable. Ret. And in that case, that would be self. Right. And in that case, the function will be parameterized by two things. Oh, okay. I think I know what we need to do. So what we need to do is we need to have a type parameter for the return type. But that type parameter on its own is not concrete. It's another trait, right? It's a type that says anything that can be converted into result is fine, right? So anything that can be converted into result is fine. And then we will implement that. We will implement unit for that one. So let's have actually a type that represents this. So trait into CLI result. Yeah. Anything that can be converted into CLI result. And that should have a function that translates whatever input into CLI result. So transpose or something. Let's call the function transpose or into. I don't know. Maybe this is it conflicts with the standard into library, but it's a standard input trait. But let's call it into CLI result or something like that. I'm thinking on the fly here. And what this needs to take is to take a type that we don't know. So input, or let's say ret. And that is a type that we really don't know. So that's going to be input. And returns result CLI error. Okay. So, okay, who's input? I mean, we don't know what that is. So in that case, we will I think make this parameterized by input. And in this case, we will say, okay, we actually don't really need to return result. We just need to anything that implements into CLI result, which is a constraint. We need to, I mean, we can't just write this. I mean, we either say impl, which I don't think Rust supports yet. Yeah. It's still, yeah, it's only allowed in input arguments, not output arguments. So alternatively, what you can do is say, instead of putting this as a value like this, we can say ret or output. And define this here as output, as also another generic type parameter. But we can define output and say, okay, output is anything that implements into CLI result. And into CLI result here needs to take an input. And the input in this case will be the output of my function call, which I actually don't know. So we haven't defined here what is going to be that output. But I think actually thinking about this, I think this is, yeah, this is not output. This is ret. This is ret. And this is ret. And we need to define output here as well. And I need to define in CLI handler ret. Maybe ret here confuse this. Ret type argument ret CLI handler ret equals. Actually, by the way, I think also this should be potentially this. Or maybe I should standardize on where. All right, missing generics for into clear result. So into clear result, let's actually look into how Axum does it. Right, so Axum actually does that exactly, right? What we have is we have something called into response. Let's look how it looks like into response from request. Oh, that's interesting. There, into response trait actually takes no type parameters at all. Into, which is very interesting. Oh, I think it's still building. Let's try and find it. Into response should be trait. Yep. Yeah. Okay. Into response doesn't really need to take arguments because it's implemented over a type. Wait, how did I think about this? And returns response. I'm a little bit idiot here. This is actually definitely true. So this doesn't really need an input. I mean, because it's self what we care about here. Yeah. And we're constraining here. So we're saying, okay, you can, any handler, any CLI handler, just needs to return anything that can, it just implements this trait. And I'm actually not even sure if that bound needs to be put on that trait level like this. And it can be, of course, like what we did before. So where, no, not where. You can say type into clear result. Yeah. And this one, just cool. Here, okay, let's review this one now. So this actually needs to be a little bit less complicated now. So fn once returns any type, let's say out, and output just needs to implement this trait into clear result, and we don't need ret anymore. So what happens is that when we execute a function, the function returns a value, like just imagine like x equals self, and the output itself is output, and output implements into clear result. We need to execute we actually don't, I mean, we either decide to convert the output here or also return something like output and make a decision on a on an upper layer to convert output. I mean, we know that output implements into clear result. That's part of the bound. So we know that we can convert that into result at any given point in time. We can actually have this test here as well. So let's say that we're calling this. So we have x. What we can do is say, okay, also we want to verify that x can call into clear result, and that also should compile. All right, so let's see what's happening here. What is R? I mean, R doesn't make any sense. We don't need R. F, the CLI handler needs ret, and ret is the return type, right? So we need to define this here. We can say type ret equals output. Okay, let's compile. I want to see what's happening. So the trait into clear result is not implemented for unit. Yes, that's exactly what we need, right? So what's happening right now? I mean, we basically we're back to square one, but with a difference. Right? And the difference here is that our function no_op returns nothing. Our bound here, fn1, says that, okay, we expect functions that, or at least we are implemented for functions as a trait for functions that take no arguments and return anything that can be converted into CLI result. Now, what's this function, takes no arguments, which is true, but returns unit. And unit is not implemented. In fact, we actually have no implementations for this trait yet. So what we can do is implement unit. We'll basically implement for clear result for f, or let's say I, where I is units. Can I do that? Or should I actually do this? Does this work? And we need an implementation. I think it works. I guess private trait into, okay, yeah. All these things need to be public. And we don't need to run to do. What we need to do is execute we essentially need to return okay every time, because the function that doesn't return anything, we cannot communicate with us if there is an error. We will always return okay. And that compiles. I hope you really like this. I mean, it doesn't really compile, but almost compiles. I mean, what fails to compile is the simple example, which now, I mean, has nothing to do with what we wrote written here. But at least that code compiles. Like, the only issues here are just linter errors because we're not using this here. But at least we know that this part compiles, and that's our validation. The other thing is that we just don't want to implement this for a function, like the takes or a unit. We also want to implement this for anything that returns actually result of something, right? So actually anything. I mean, also that's like a very fair point. Do we want to enforce all our handlers to return result of unit, or do we want to allow them to return data, like any value? And in that case, if we are returning values, if we're returning data, what would the plumbing do? How do we propagate it back to user? Like, let's look into the simple example and think here. Okay, we're gonna get back to this one. So for instance, let's say that this one, I mean, currently everything returns result. So the value here, that x equals this thing, x is a result. Yeah, x is a result of unit and clear, which we can make everything parameterized generic so that any, whatever they return can be propagated back. But first, we cannot guarantee that all these return types are the same. So we need to have maybe an upper bound trait or something that all these traits need to implement, similar to into clear result, so that anything that implements this trait can be passed up. But the other problem that we have here is that because we're going to have this structure that allows intermediate operations to be executed before you reach the end. So for instance, like we can have something like here execute extra logic, right? So we want the user to supply a handler for this level, and that level will be executed before we execute this one. In that case, okay, what are we gonna do with the return value of this intermediate level? All right, if there's a return value, what do we do with it? Because we can't just return this, because we need to wait until we have the return value of the bottom one in that tree, in that hierarchy. So that would be a little bit confusing, I think, and I think it just adds complexity. We can, I think, safely assume that commands in command line arguments, in command line applications shouldn't return data. They should just execute, right? And maybe print, have side effects essentially. And the only thing they communicate back to the environment is either errors, or we can have another mechanism to allow them to pass maybe channels so that they can, talk to each other or whatever, but not return. I think this makes sense. In my head, at least, it does. So in that case, we were going to enforce everyone, really. We can say, okay, hey, you can only return CLI error, or actually, it should be really any type of error as long as it can be converted into CLI error, right? So we can say, okay, hey, this is implement over E, and we have a bound over E where E is implements into CLI error, right? And in that case, we actually shouldn't do that. What we should do is just return self. But self, yeah, self. Yes. So here we return CLI error. We just need to map error with into, right? Because the error that might be returned is something else. We just need to return CLI error. And because we have this bound, we know that E can be converted into CLI error. We just need to convert it if there's an error. So that's why we need a mapping error. And that really should work. And it seems like it's working. So going back here, we can actually have another test, right? So let's add another test here. And we're not testing empty functions. We're testing result functions. So this one should have a result that returns nothing, but also the error should be, we need to find an error type that makes sense here. Let's say that it returns standard IO error. I think box or something, box. Then, yep. Just an imaginary error. Not imaginary, but I mean, any other error should be converted into anyhow. Oh, okay. That's actually fine. Can we do that? And say here we are going to return okay. Yep. Okay, so that's another function, another shape, but that one, returns shape similar to what you expect, and this fails to compile. Let's look why. Yeah, so what it says is that there is no way to convert stdio error into CLI error, right? The trait from anyhow error is implemented for CLI error, required for error to implement. Okay, so IO is a standard library error, and it sounds like it doesn't implement conversion for it unless, or at least we need to convert it into anyhow error before we can convert it into CLI error. Yeah, we need to do this in 2 steps because our error here can only convert from anyhow error. Which brings me to, can I actually do this? Can I say box then standard error? Will that ever work? That's probably not going to work as well. Yeah. So that's going to be an open question. I'm going to leave this for now. So I'm not going to bother myself with error pass through, but we can have any other type of error. Like actually anyhow error should work itself, right? So anyhow error should just work here. And this actually compiles just fine. So now these two functions can be passed into handle, right? So either function takes no arguments and returns nothing, or a function that returns a result as long as it follows that shape. The error type must be convertible into CLI handler, CLI error, and but this output needs to be unit, like it cannot be anything else. For instance, if it's U32, this is going to fail to compile, as you can see. Like or let's just put a number here, so that's happy. Yeah, so it says that because, you know, we just don't have an implementation for that trait, and the trait we have here specifies that the result we are expecting, I mean, the into CLI result is only implemented for unit and we can relax this, as I said, like we can make this, you know, generic parameter, but we're just gonna drop it. Like we're not gonna be able to do anything with it. Maybe this is a good idea, right? To say, hey, okay, whatever value you return, I mean, feel free to write your function the way you like, and we will just ignore the return value, or we can restrict, we can ask the user to write the function. It has to be unit, like there's no way. So I'm gonna leave it unit for now, and then we can revisit that decision if it turns out to be overly restrictive, right? I think even better, we can have a result type of our own that has units, like CLI result or something, right? We don't have that at the moment. You can actually have this in here. We can have a type pub type CLI result, and that would be just result of this and clear, which is going to be like this. Just a convenience type alias. And in that case, we're going to say, okay, it's not clear, we're just going to be clear result. Yeah. So now let's get back here and see, okay, how can we do that wiring again to make this? I mean, this should compile now. No. Oh, there's other issues. Wait, so trait into clear result is not implemented for result. All right, I didn't undo the U32, which is in handler here. U32, that should be unit, and that should be unit. Yeah. All right, so what is the error now? It's result. Consider importing the type alias clear result. Clear result, we should put it in prelude. Public use clear result. Would that work? No. Super. Okay, clear. Run again. Okay, cool. So let's take a look here. No up expected result clear found unit. Okay, that's actually the original error that we have. I mean, that's because our code here doesn't, or should actually do this, right? So we said like no op returns nothing, and no op really is supposed to return result, because we didn't really use the new types, like the whole handle or handler thing. I think you're right. So actually, we need to do that, right? We need to have this machinery right now that takes CLI opts and, I don't know, takes the handlers that we have here and extract, run call, convert to the output, like that does all of that, so that wiring should work. So let's actually take a look first if there's any questions. So let's take a break and I don't know why my camera keeps freezing. All right, hope this works now. Cool, any questions? All right. Doesn't look like there's any questions. Let's move on. Cool, cool, cool. Okay, cool. So what do we need to do now? Next step is once you have this, we can actually break it down into levels, or at least one source of inspiration that we have looked at in Axum was extensions, right? Or from request parts. From request parts, what it did is, I mean, this is a trait that tells you, okay, any type that can take a request and extract what it needs to get whatever it wants is a valid argument to handler. Right? And then we had like path, JSON, like there's multiple structures that implement that trait. In our case, we need something similar. We need to say the types that you can pass into the arguments of our handler. So our handler here, at the moment, we really didn't implement this for any other type. Like we only said, okay, we accept functions that take no arguments. That is, fine if your command line doesn't really do much. But if it needs to take arguments, then we need to implement this we need to have another implementation here. And that implementation needs to take input, let's say t, right? And, let's call it I1, because we're gonna macro this right now, just so that we can support many arguments. So if it takes I1, right? And in this case, because that function takes I1 and returns output, we need to pass, that self needs I1 as input, right? That's fair, right? But how do we get I1? Where do we get it from? We cannot add arguments to call. We can't do that because call is implemented on it's defined at the trait level. It has to figure out how to get I1 from some input. And there is no input at the moment, like zero input. So what would be the input? The input here would be the command line structure, maybe the entire CLI object, like this entire thing, CLI opts or whatever, like any parser, like the bigger object. That's one way to think about this. Another alternative would be can you still hear me? I'm not sure. I've seen my screen a little bit frozen here. And I just realized also that I wasn't on screen sharing for a few minutes, so maybe you haven't seen what I was talking about. Cool. Yeah, I was essentially discussing this. So where do we get the input from? So we need something similar to request. We need to have request as an input or something similar. But what is a request here? A request here is something similar to CLI opts maybe. But then we need to figure out in this case, okay, how do we extract or find I1, which is like a generic type parameter, from CLI opts? And that is where extensions in Axum come very handy. In Axum, actually, they don't pass CLI opts. We don't pass something similar to this. They have their own type, of course, right? And the type will be something like request, or we should call this something like CLI args. Right, something like this, as I said, basically an internal type or a trait. And actually not a trait, it's struct. It has to be a concrete implementation, a concrete type. So CLI args of some sort, right? And okay, that's cool. We should say args here. What is this and where is it coming from? And how do we extract from that type? How do we extract I1? Which is type we don't know. So let's actually first modify our function here to take args, CLI args. We should actually call this CLI collected args. I'll just collect args for now, right? Okay. Yep. And you know, like we need to do this on every implementation, except in this particular one, we're not gonna bother by because we're not gonna use it. Collected args. Potentially by reference, but I'm actually not sure. And we don't have a type called collected args, so we're gonna have to implement it somewhere. I'm gonna just call this args.rs. And I'm gonna make it like an empty struct for now. All right, so that's a empty struct, and we just need to import it here. I'm not actually sure if it should be public though. Potentially not. Like, should not be public, I guess. So we should fix that later. But we need to make sure that args, yeah, should maybe remove this. Yeah, so it's not public. And now that works. Let's see what is the error here. So what did we do? I1 is output is not constrained by infiltrate. It just, I think it's just confused, doesn't know what output is. What I1 is. Unconstrained type parameter is not constrained by infiltrate itself or predicates. It's not constrained by infiltrate predicates. Okay. It sounds like it needs to be constrained. Like it needs to have some constraint. Why is it complaining also about output? I don't get that one. I don't get that one. The type parameter output is not constrained. Why did it work? I mean, why does it work here? So output here is constrained. Okay, that makes sense. Output here is also constrained, actually. Output is constrained. That's an interesting error. And I'm not sure actually if we should really constrain it. Does it really need something like this? No, there's nothing to do, I guess. Type I. Maybe we need to say type I. Actually, I have an idea. I mean, this is similar to handler, right in Axum. So let's look into how handler was implemented and how does it look like. This is handler. So there's a type T. Oh, I remember now. I think I remember T was a single type. That's in the handler. That's the top level, right? And uh, handler has call, which doesn't really depend on T actually at all. Where is T used? It's in layers. Oh, you don't really need something like layer, I guess. So we're gonna wrap up in 10 minutes actually. We need to get a good closure, like stop at some point. So let's look into these handler macros. So you can see here, like they collate all the arguments as a single type, and that type is a tuple, and it needs to be. So what appears to be the case is that you cannot basically have an extra type parameter in an implementation of a trait that the trait doesn't define. Like so, and that actually makes sense in a way. So the clay handler, which is this one, needs to have another type parameter. So something like input. And just we don't really need to do much with it. I think so. What we need to say here is that type input is, in that case, should be I. And not just I. I think it needs to be a tuple, an empty tuple I. A tuple of I. What does it look like here? Tuple of something. There is M. It has to have a. It has to have at least two types for it to be a tuple. Okay, M and I as a type argument. And M and I here are basically all the inputs here, and they are lost. And does M exist on the handler? No, it doesn't. So it sounds like my assumption is actually not true. You don't have to. You don't have to have all type arguments defined on a trait. But I'm not sure how to express this. So fn1 should be, I mean, this needs to have a name as well, right? So when we say fn, okay, so you can see here, like it goes through, essentially passes one by one, which is I guess. And this one takes tuple and adds comma at the end. So you can see like it's actually not happy about the syntax because it's at the end maybe. Okay, in the input. Okay, so when they declare, they cannot do that, right? So they can do that. It needs to be I, and maybe M, which I really don't know what M is for. And when we get to CLI handler, I mean, the way we use it here is that we can say, okay, input is M and I. So that way, at least we are binding this to a specific type. And what's also interesting is the order that they define it here. Like they actually do it at the end, right? So M first and I. What's also different here is that we are using type, so that our trait has associated types, while their traits have something like this, right? Where here, this is unit. Here, this is M and I. Yep. No. And we don't need this. Okay, and our handler, actually this seems to work. I don't know if we need M, I mean, we'll get back to this. Missing generic, of course, because we need to now define the type of input. And that's not cool. Because I didn't want this. I mean, the CLI handler that we expect here should be it should be generic over whatever. Okay, no, actually. Well, first, a call needs to take input, and the input here should be collected args somehow. So let's say A, the type is collected args, which we really can't do that because it's okay. A equals to do, and call needs to take A. But that's not the problem. The problem is, what is the type parameter that we need to pass here to input? And in this case, we actually don't know. The input should be type maybe X, which we don't really know. So we are also parameterized over X. And in this case, we need to pass args down. Wait, no, we don't need to pass args down, but we need to extract I from the input, which we don't know how to do at the moment. So we just assume that somehow from args we can get the type I, right? And say, okay, let I equals something like this, and then we can pass I down here. This is really similar to what we've seen last time. I mean, that function just doesn't exist. Yeah, right? And we can actually implement it. Like we can go to args and just, add a function impl collected args and have pubf and get, which takes type T, and then, I don't know, takes self and returns maybe option of T or something. I mean, if it exists, right? And we just don't know how to get that right now, but we can to do. And in theory, that should compile. And I know it complains that this needs to be snake case name. I'm just following the same style that you can see here, and essentially that's why there is this line, like non-snake case line that you can see, which actually I would actually just do that here as well. It's on the impl, like it's here. Just because like they need to have this automatic mapping, and for every type. So they don't know how to generate a name, so they just use the same type name, which is exactly what we're doing here. We're just gonna automate this with a macro later, right? Okay, cool. The only issue here is that I returns option as I defined, and what we can just basically do is that we can say, okay, unwrap the option if it exists, or we can return an error, right? We can say, okay, essentially the type that you requested, they were trying to wrote a function for that type, we couldn't get from the collect argument. So there's an issue here that we just cannot resolve. And I think a good way to represent this is to have another type here called internal, or internal error or something, and that should have a message, right? let's call it internal error, and there is a message here, right? And in this case, when this happens, we just need to return that. We know that output is anything that can be converted into clear result, but we actually just cannot return output here, right? Yeah, we just can't actually. So that actually will not work. We just don't know what to return here. We need to return something that can be converted into clear result. That's we still need to return the exact output type, which we don't know. It's a generic, so we just cannot return that one. So we actually should structure this a little bit differently. Instead of returning output, we should just return result of output and CLI error, right? And in this case, we would say that this is this shouldn't be called into CLI result, but it should be called into CLI output, right? Yeah. So let's go there. And into CLI output will return the type we are implemented on. So that is self. No, not self. So into CLI output is ret. Yeah, that should be fine. And instead, that we actually return result of ret and clear. Well, not clear per se, but anything that can be converted into clear. Clear is fine for now. All right, and so let's review this. So into CLI output, let's rename this. So this is implemented on a type, and we just need to, we basically need to be able to convert this into a unit. Like anything, we basically take anything and convert it into. I'm actually not sure if we really need this. I mean, if it's structured that way, we might just cut that layer and say, okay, any T would work as long as we have a blanket implementation for unit, right? If you want to restrict this. So that is something actually we can follow on, and I'm gonna clean up the structure of stream. But I think we have relatively kind of decent structure here. And basically what we need to return here is just error, so CLI error, internal error, and that internal error should have a message saying type, and then we can, this needs to be type. We need to stringify part of the type input and say something like TY, which is we're gonna figure out when we do that with macros. But type something could not be collected from the input arguments. Check that handler is correctly. Yeah. We just need to remove maybe that. Yeah. So when we unwrap or else, and we should return this, maybe, or question mark. That's okay, I think. It returns type T, which is defined, I think, on the option. So we actually need to have another value. Actually, I don't think I should certain wrap or else. I think it's okay or else. Or I mean, maybe easier. Sorry, maybe I got a little bit tired. I think it should be sum of I equals args here, and then we can say else. Yeah, return error. And semicolon, I think. And CLI error needs to be imported somehow. Arguments to this enum variant is a string, so we need to have to owned. That should generally work because I is from type I. Self should take I. And the only issue here is that self returns, I mean, that's the part of the remaining structure we need to fix, because self returns result and doesn't return result anymore. Right, F returns output, and output is into CLI output. So we need to do that. We need to fix that plumbing that I just broke before. And cool. All right, we can wrap up here and continue next time. I will definitely work on this off stream, or maybe I can make other streams maybe a little bit earlier for folks who can join. But you can also follow up the code on GitHub. Thank you so much for joining, and I see you next time. Bye bye.